Hey, what's up, guys? This is Chen here again. So this time, LeetCode number 115, distinct subsequences. Okay, so now this time we have two strings, right? S and T, and we need to find how many distinct subsequences of S which equals to T, right? So basically, for example, we have this rabbit and this rabbit and this rabbit. So the answer is 3 because we have 3 different subsequences in S, right? That equals to T, right? Here we have 5, so that's the answer, and the constraint is like 1000, right? I mean, so this is another like two strings DP problem, right? Because every time when you guys see this kind of two strings and you find the number of distinct subsequences, and with this kind of like 1000 constraints, so most likely it's going to be a n squared time complexity DP problem, right? So how can we solve this one, right? I mean, maybe you can start with a simple version. I think we all know, right? Let's say we have S and T, right? So if I ask you to tell me if T is a subsequence of S, right? I think most of you should be able to solve that, right? So how do we do it, right? We simply you use two pointer, right? So we have a I for S and we have a J. We have a J in this T, right? So basically every time we find a match, right, we move both I and J forward, right? And if the current one doesn't match, then we don't move J, but we keep moving I forward until in the end we check if the J has moved to the end, right? If J has moved to the end, then we know T is a subsequence of S, right? So that's how we check if T is a subsequence of S. But for this one, we need to find basically so here we're only finding one of the possible subsequence, right? But here we need to find all the possible subsequences, right? Um, so how do we do it, right? I mean, for this kind of uh, two strings DP problem, right? We have I here and we have J here, right? So what we usually have, we usually do this, right? So if I is equal to Sj, right? We check this one. If this one is the same, then we'll do something like depending on if this one is true or not, we'll have like different type DP state transition function. But let's define our DP state first. So we have DP I and J, right? So this one equals to from 0 to I and 0 to J, right? How many subsequence, right? Do we have? Okay, and in the end, we return the DP of -1 and -1 will be our final answer, which means for the whole S and T, right? And then let's look at our different scenario here, right? So let's say let's look at if this one does not equal to the SJ. Sorry, this one is the TJ, right? So let's say if the I does not equal to J, and then what do we have, right? If it doesn't, if they're not the same, then we only have one option, which is dp of ij equals to dp of what? Of I minus 1 and j, right? So this means that, since the current I and j, they're different, right? Then we have to go back. So basically the number of dpij, right? So the number of subsequences equals to the number of dp I minus 1j, right? Because since the current one doesn't equal to this j, we cannot match I to this j. So then we have to go back to I minus 1. Hopefully the I minus 1, the dp I minus 1 can somehow match this j, right? And here, keep in mind that based on our definition of this problem, we cannot consider dp I and j minus 1. So this one is not right. For some of the DP problem, whenever this one does not equal to each other, sometimes we get a maximum between these two, right? I don't quite remember which problem was that, but for this one, we cannot consider this one. And why is that? This is because, because for this problem, we need to know, we want to know like if all the characters from 0 to j it's part of the subsequence from the 0 to I, right? So if we do this one, if we do something like this, then it's not right, because our definition is that from 0 to j, basically the j's character has to be matched somehow. But if we do this one, that means that we don't care about the current j, right? Which is wrong based on our definition. That's why if the current I and j they're not the same, the only option we have is go back to I minus 1 to make sure the I minus 1 can include from 0 to j, right? And okay, so that's that. And how about if the si is equal to tj, then what's gonna happen, right? So the first one is gonna be this one, right? So we have I, j. This first one is this. It's gonna be a dp I minus 1, j minus 1, right? Because so again, so now, right, since the I and j they're the same character, right? Let's say this one is d, right? This one is also d, right? They are the same. So dp I minus 1 j minus 1 means that so from 0 to I minus 1 and from 0 to j minus 1 we have, let's say we have 10 different subsequences, right? And since I and j are the same, so which means by adding I and j to the end of this previous state, we can still be sure dpij has 10 different subsequences, right? But that's not all, right? So here, the tricky part for this one is that we also need to consider this dp of I minus 1j, right? So the reason being is that it's because even though the I and j they are the same, but we still have the option to ignore the current I, right? So for example, we have I remember we have the rabbit, right? So rabbit, and then we have a rabbit, right? So basically, if the I is here and j is here, right? Sorry, I think there's like not enough space here. So if I is here and j is here, and then if we go back here, right? So from I minus 1 here, we may still find like match, right? Without moving j's back, right? So that's why this one is regardless. Needs to be considered regardless for both conditions. Okay, and yeah, I think that's it, right? I mean, so as you guys can see, so that's basically the state transition function for us. Okay, cool. I guess we can start coding. Oh, where is my definition here? So first we have this m equals to length of s, right? And then we have n is equal to length of t, right? So we have dp of this 0 for n plus 1, this for this in range of n plus 1, right? So we increase the length by 1, trying to make sure that I minus 1, j minus 1 will not go out of the boundaries, right? So basically, that's why for this one we have this 1 to m plus 1, right? And for j in range of 1 to to n plus 1. So basically this now here I and j means that the length of s and t. That's why we start from 1 to m instead of 0 to m minus 1, right? So we check if the si, so here we do I minus 1 equals to t of j minus 1, right? So this I minus 1 means that, since this I and j are 1 based, but the s is 0 based, right? That's why, we need to convert this 1 based index to the 0 base. Okay, so if they're the same, then the dp I and j equals to the dp of I minus 1. So that's the first j minus 1. That's the first scenario, right? Plus the dp of I minus 1j, right? Else we don't have any other options but to go back to the dp of I minus 1j, right? And then in the end, we return the dp of minus 1, minus 1. So that's basic the idea, the state. But we still need to figure out, set up the base case. So as you guys can see here, right, at the beginning, everything is 0, right? So if we don't set up the base case, obviously in the end, everything will still be 0, right? So then what's the base case? So the base case is like this. So base case is either like s is equal to 0 or the t is equal to 0. So that's basically the two base case category for the for this two strings problem, right? So for this one, let's say if s is 0, then what's going to happen? If s is 0, then it means that everything should be 0 because we don't have any subsequences that can match t, right? Then we can, since everything was set to 0 at the very beginning, we can ignore that. And then the other one is t, right? So if the t is equal to 0, right? So then what does it mean? It means that all we need to find is that, if t is empty, it's not 0. If t is empty, then the only valid subsequence is also empty in S, which means it's 1, right? So basically it means that, let's say S is ABC, right? And then the T is empty, right? So an empty subsequence can match this one, right? Because for any string, an empty subsequence is always a subsequence, and only this one can match the T. That's why we can do this for I in range of m plus 1, right? And then we have dp of I 0 equals to 1, right? So 0, 0, 0 is also 1. 0, 0, dp 0, 0 is also equal to 1 because a string empty, if both s and the t are empty, they still have one match subsequence, which is empty itself, right? Yeah, I think that's it. So if I run the code, accept it, right? Yeah, there we go, right? So the time complexity, right? It's n square, and space is also, it's not n square, actually it's m times n, right? Space is also m times n. It's time, space, right? So I mean, I think since we only consider like the the I minus 1, right? We might be able. I think we should be able to reduce this time complexity from m times n to n. Sorry, for the space complexity because of this, right? So which means that along the way we can use like a temp variable, right, to store this previously state, and then we in the end we set it back. I'm not going to do it here. You know what? Let's try to do it. Let's see if we can figure it out, right? So which means all we need is like this. We have 0 of n plus 1, right? So we don't need this dp anymore. Okay. And this dp of 0, I think yeah, will be 1, right? In this case, let's say this. So here, so we have old DP, okay, DP of this, right? And so in the end, we have DP equals to the old DP, right? So here we have a -1 dpj, right? So dpj, so we're gonna remove this one, right? Here is gonna be this one and this one. Oh, so here, oh, we're gonna need the old basically, right? Yeah, old. Okay, here we have this. Oh, then we don't need this one, right? Yeah, basically before calculating the current one, right? If we do this, I think this should also work. Yeah, yeah. So that's basically how we improve this time complexity, right? Since this one only, like I said, since this one only depending on the previously uh, dp, right? dp is the first dimension. We can just use a temporary variable every time to calculate that to make sure, and then we only maintain this one dimensional dp. So this one is faster because we use less space. Okay. Yeah. Anyway, so that's it, right? Basically, this one, I think we start from the simple version, right? I mean, to check if this string t is a subsequence of string s, and then I think somewhat we use the similar like ideology, right? And to apply this one to extend this one a little bit to get the count of the subsequence, right? By getting this kind of state transition function. Yeah, I think that's it. And thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.